Hello dear friends, welcome to Math and Physics Simplified. Today we are going to discuss the questions from chapter circles and areas related to circles, and we are taking this question paper. This is a standard question paper from the CBSE site. Okay, let's start. Our first question is, in the given figure, a tangent has been drawn at a point P on the circle centered at O. If angle TPQ is 110 degree, then angle POQ. So we have to find this angle, right? And it is a one more question. So you know the radius and this tangent. Radius and tangent will make 90 degree angle, right? 90 degree. So the remaining part, angle OPQ, you can see that is 110 minus 90. So 20 degree, right? This is 20 degree. And you know the radius is same. OP and OQ are same here. So it's an isosceles triangle. So this angle also will be 20 degree. And in triangle OPQ, all angles should be, the sum of angles should be 180 degree. And you know the other two angles, 20 plus 20, 40 degree. And the angle POQ equals 180 minus 40, 140 degree. So option C is the correct answer. O is the point of intersection of two chords AB and CD of a circle. If angle BOC is 80 degree and OA equals OD, then triangle ODA and triangle OBC are. So from here you can understand angle BOC is 80 degree, opposite angle definitely this would be 80 degree, right? And you can see this angle, this ADO and OBC are the angles on the same segment. So those are equal, correct? Two angles are equal. Two angles are equal for these two triangles, okay? So you can use the AA criterion for similarity. Triangle ODA and triangle OBC are similar triangles because two angles are equal. And we have to check whether it is isosceles or not, okay? So for similar triangle, you know the ratio of their sides will be equal, right? So this angle's opposite side is OA and the same angle is OB. So opposite side will be OC. OA divided by OC equals AD divided by BC equals OD divided by OB. Okay. And this OD equals OA. In this question, it is given OD equals OA. So you can write OA by OC equals, instead of OD, you can write OA itself, OA by OB. So as the numerators are equal, denominator will be same. OC equals OB, correct? OC equals OB. So this is also isosceles triangle. So these two triangles are similar and isosceles. Option B is the correct answer. Choose the correct option. So you know this instruction, right? Both assertion and reason are true and reason R is the correct explanation of assertion A. Both assertion and reason are true and reason R is not the correct explanation of assertion A. Assertion is true but reason is false. Assertion is false but reason is true. You have to select it for this question, okay? So assertion is, if the radius of the sector of a circle is reduced to its half and angle is doubled, then the perimeter of the sector remains same. So perimeter of the sector, how will you find? Of a sector. So if you have a circle and there is a sector and you have to find the perimeter of this sector, okay? Actually, perimeter of this sector means you will have two radius, okay? So two radius plus this length of the arc. Length of the arc equation, you know, theta divided by 360 times 2 pi r, okay? This is the perimeter of a sector. And if the radius of the sector of a circle is reduced to its half, means this radius will be r by 2. So new perimeter, we can find this and we can finally we can compare whether it is matching with the first perimeter. New perimeter is 2r. Instead of r, we have to write r by 2 plus, instead of theta, what we should be write? Angle is doubled, I'm sorry. Angle is double. So 2 theta divided by 360 times 2 pi. Instead of r, we have to write r by 2. Okay, so here the 2 cancel, and here this 2 and this 2 also cancel. So here r plus theta by 360 times 2 pi r. So theta by 360 times 2 pi r. This length of the arc is there, but instead of 2r, here in the new perimeter it is r. So perimeter is getting changed. So this is false. Perimeter of the sector remains same is not correct. It is false. The length of the arc subtending angle theta at the center of the circle of radius r equals pi r theta by 180. That you know the equation. Theta divided by 360 length of the arc times 2 pi r. So when we cancel these two, we will get theta pi r divided by 180. That is same as pi r theta by 180. So this is true. So what will we select? Assertion is false, but reason is true. Option D. The minute hand of a wall clock is 18 centimeter long. So I have just drawn here. This is 18 centimeter. Find the area of the phase of the clock described by minute hand in 35 minutes. Any time you can select. I just selected maybe 3 p.m. to 3:35 p.m. You will get 35 minutes, right? And I'm not drawing the hour hand, only the minute hand I'm drawing. And you have to find this area. Okay. Minute hand will rotate like this and reaches here, and it swipes this much area. You have to find that area. We can do it step by step. So first step is angle swapped by minute hand in 1 hour. In 1 hour means it completes the circle, right? It completes the circle. So it will cover 360 degree. Correct? So 60 minutes means it covers 360 degrees. Angle swept by minute hand. So in 1 hour 360 degree. So in 1 minute, 1 hour means 60 minutes. So in 1 minute 360 divided by 60 degree. Angle swept by minute hand in 35 minutes. For 1 minute 360 divided by 60. For 35 minutes, just multiply with 35, right? So I'm cancelling here. 1 6 is 6, 6 6 are 36, 35 into 6, 210 degree, right? So this much angle is swept by the minute hand in 35 minutes. Okay, so we know angle and we know the radius. The minute hand is acting as a radius of that circle, right? 18 centimeter. So we just want to find the area swept by minute hand in 35 minutes. Okay, that is, the equation, theta divided by 360 times pi r square. Okay, theta is 210 divided by 360 times pi is, you can write 22 divided by 7. It will be easy for you for the calculation. R square is 18 square. 18 times 18. And you can cancel out all those things. 0, 0 here cancel. 21. 3 7s are 21. 1 7 is 7. 2 36 are 18. 1 is here. 1 and 9 is here. 22 times 3 times 9. 594 centimeter square. Okay, so this is also 3-mark question. AB is a chord of a circle centered at O such that angle AOB equals 60 degree. So this angle is 60 degree. OA equals 14 centimeter. Then find the area of the minor segment. So this is the minor segment. You have to find the area of this. So area of minor segment equals area of sector, right? OA, if you name here any other letter X, sector OAXB, you can give capital letter. minus area of triangle OAB, right? So if you subtract the triangle's area from the sector's area, you will get the area of this minor segment, right? And here you, I think in the previous question, means in the previous video also I have explained how did you get this triangle as equilateral triangle. If there is a triangle and the angle is 60 degree and these two sides are equal as they are radius of the circle, these two sides are equal, definitely this side, these angles are equal, and that is 180 minus 60, 120, 120 divided by 2, 60 degree. So each angle is 60 degree for this triangle. Each angle is 60 degree. So this is an equilateral triangle. For equilateral triangle, you can use the area formula directly. Root 3 by 4 a square. This minus is from here only. Okay. Area of the triangle OAB is root 3 by 4 a square, and area of the sector, you know, theta divided by 360 pi r square. Okay. And theta is given 60, 60 divided by 360 times 22 divided by 7 into r. Radius is 14, so 14 square minus root 3 by 4. A is the side of the triangle, that is also 14 square. When you calculate this, you will get 102.66 minus 84.77 equals 17.89, and you can approximate it to 17.9 centimeter square. So this is the area. Prove that the lengths of tangents drawn from an external point to a circle are equal. Using above result, find the length BC of triangle ABC. Given that a circle is inscribed in triangle ABC touching the sides AB, BC and CA at R, P and Q respectively, and AB equals 10 cm, AQ equals 7 cm, CQ equals 5 cm. And this first part of this question I have already done in the previous video. I'll share the link in description also, and I'm just doing the second part of this question here, and if you write completely, then only you'll get 5 marks for this question. Okay, so please prove this first. I'm not doing here because I already did that, and the second part I'm doing here. Okay, so you know the sides AB equals 10 centimeter and AQ equals 7 centimeter, CQ equals 5 centimeter, and you have to find the length of BC. Okay, so AB equals 10 centimeter and AB is actually BR plus AR, and it is given AQ equals 7 centimeter. So AQ equals 7 centimeter means AR also equals 7 centimeter, right? So AB will be 7 centimeter plus BR, and this AB is 10. Okay, so BR equals 10 minus 7, 3 centimeter. BR is 3 centimeter. So definitely BP is equal to 3 centimeter. And as CQ is 5 centimeter, it is equal to CP. That is also 5 centimeter because CQ equals CP. So you got BP plus CP. This is actually BC, correct? 3 plus 5, 8 centimeter. I hope you understand. BC is 8 centimeter. That is the question. Hope you understood all the answers and explanation. Please consider subscribing my channel. Thank you.